Hello, everyone.
Hi.
Hello.
Greetings.
Howdy.
Can anyone hear me?
Yes.
Yes, I can hear you, Stephen.
Good.
Heat wave. Is it as hot in the UK as in the US at the moment?
No,
It's
thanks.
it's a bit cold in Scotland.
We're above the jet stream. It's southern Europe that's below the position. The jet stream is getting a pounding at the moment.
I think it's 15 degrees at the moment in centigrade.
Whereas in Europe, the places are approaching 40 degrees centigrade. Yeah.
Sardinia is expecting up to 47 degrees on Tuesday, apparently.
Now, John, we've got a few things on the agenda. Let's get underway, and others can join as they come in.
Yep. So, could you list them, Robert? Because or we could make a list as we go along. How would you like to do it?
Okay. Well, I mean, what I can do is I can put our current agenda points into the chat. So we received an email from you, which is your consistent SRM storyline for refreezing the Arctic as a main thing to talk about, and then other things that have been raised with me are the work that some of us have been doing with Stephen on efforts to promote marine cloud brightening, and the whole question of comparing the climate cooling effects of various methods. So those are 3 points. So why don't I just put those into the chat now? So
okay, and then concerning my own storyline, quite a few issues have been raised, mainly on the thread, which I started on the storyline, but we can discuss them here. For example, Ye Tao gave a very aggressive critique of stratospheric aerosol injection, which I think was a little unfair. And he said, watch this video, and I haven't had a chance to watch it, so I felt I couldn't answer him straight back until I'd done that.
I haven't seen that note from Ye. Has that just recently come in?
That was a fairly immediate response to the storyline idea.
Okay, and did that circulate to other people or just to you?
I think it went to the whole, to everybody, all 3 groups.
Okay.
I know that, and some of the criticism was definitely not valid.
Roger, I can't hear you very clearly. Can you raise the volume?
Yeah, I think I can.
That's better.
Oh,
Or
I'll
just get closer to the microphone. That's better.
Yeah, at least the criticism about interference with, or possible interference with outgoing long wave radiation is invalid because the particle sizes are too small to interfere with long wave infrared. It's also, he didn't address the fact that it goes away pretty fast if there's anything discovered. And the other point is simply that it's even tests that are prohibited. So even if the points that he raised might have been valid, it's a good reason to proceed with the test so we can know for sure.
Yeah. Yeah, I mean that's actually an argument for starting trials or actual trial deployment in enough of an effect that you can measure. We've actually considered several of us have considered the idea independently of putting extra SO2 or SO sulfate compounds into jet fuel and seeing whether the contrails are brightened or lengthened, having a longer life.
Yeah, that's a somewhat different altitudes for jet contrails are low enough.
Yeah, they would only be for jets that are above the tropopause by the jets in the lower stratosphere. And one of our members who's not arrived yet, he probably will come, Brian von Herzen, says that it would be quite simple to arrange because the pilot could have a tank of one of his tanks could contain slightly higher amounts of sulfur compared to the normal. It would obviously have to meet the regulations, but then he could switch tanks, and one could monitor the results from space and see if there was any difference in the optical.
I did receive. You're right. The response from Yatao went to people. I got a bit confused because he started it off by talking about a completely separate point, and so I hadn't read his concerns, but it raises one of the issues that I find quite interesting, which is that people do assume that solar radiation management is a euphemism for stratospheric aerosol injection, and the reality is that that radiation management is a much broader thing, and it does include cirrus cloud thinning and possibly even now somebody's typing, can they put themselves on mute if they're while they're typing, and possibly even technologies like OTEC, which have a thermal radiation management effect. So that distinction that people raise between solar and thermal radiation management is one that that some people would like to question. But I thought that Yatao was too negative in his criticisms, like for example, saying that criticizing statement that the risks associated with all the proposed SRM techniques compared to the risks from allowing the Arctic meltdown to continue. That seems completely reasonable statement. And so the further thing is that there's a clear need for extensive research on SRM techniques, and people seem to jump to the conclusion that that advocacy is neglecting for research to assess all of these risks and benefits properly.
Yeah, so we've done our own kind of attempt at research or meta research in this group to try and assess them. Bragg actually produced a review of all the techniques for refreezing the Arctic, but when it came to doing the calculations of how much cooling power was needed to refreeze the Arctic, we had to cut down very much on the variety of techniques which would be sufficient, provide sufficient cooling power. And I did my own calculations, and I checked them with Kevin. Kevin actually came up with lower figure for marine cloud brightening than I had, which is so we did kind of reconcile our calculations and agreed that marine cloud brightening was about an order of magnitude too little for refreezing the Arctic.
Now that's a point, John, that is, I think, reflects some of the views among stratospheric aerosol injection advocates, but is contested by MCB advocates. And so where things are contested like that, I think it's essential to defer to the peer-reviewed literature debate and not not jump to advocating conclusions that may not fully understand the issues. And so
right,
yeah.
okay, so I don't want this argument of mine to stand in the way of the general principle that we need to refreeze the Arctic. And I think the argument, even if it's not even if marine cloud brightening isn't sufficient by itself, it can help. And we need to throw everything at this problem that we can. So in that respect, I think we probably see eye to eye, don't we?
Of course. Now Rebecca wants to speak.
Good morning, everyone. I'm sorry I was 5 minutes late. Even the early birds are late sometimes. It's 6 o'clock and 6:15 in the morning in Australia. And anyway,
Morning.
good morning or good evening to you. What I would like to ask is, once we think that people are here that are going to join, like I think Herb might have joined a few minutes late and Manna Joe as well, could we please have a dot point agenda in the chat? And
yes, I've put that in already, Rebecca.
Okay,
I'll put it in again.
Okay, so what that means is that people who join late, like myself and possibly Herb, haven't seen it, so I appreciate that. The other thing is, oh, that's really good, thank you. Okay, well, that's good. Now, what I would also suggest is that we might have a very high level. I mean, I've heard most of what was just said then, but I'd like someone to do a playback of the main points that have been said since the beginning of the meeting, just because then we're all in the same loop. Plus, what I have done, because I didn't see the agenda there, I've popped in the video I've just sent is in relation to item either one or two, and I won't speak about it until it's a proper place in the agenda. But in any case, perhaps John, could you give us a little recap of what you said and what others? Sorry, could I just finish, please? What I would like myself find helpful is what you said and what others have responded with, because then we're all in the same loop, and whoever joins new from now on still won't know, but at least all the people here will know. So thank you very much, everyone.
Okay, Rebecca. So the agenda is the SRM storyline, which I sent, and then Robert added marine cloud brightening, scoping, and climate cooling effects. So we've actually already started on the SRM storyline, and the first response I got from that was from Ye Tao, and he made 2 points. I can't remember what the first one was, but the second point was that he thought that the risks of SRM were greater than the risks from not deploying SRM. I think that's
Not necessarily that they're
nutshell.
greater, but that they're problematic,
Yeah.
that they're unknown. So his points were that the assertions in your dialogue include statements that are uncertain.
Yes, because I was pretty pretty strong and definite that the risks of SRM to cool the Arctic were negligible compared to the risks of letting the Arctic melt down, continue unabated, which effectively is what would happen if you relied on emissions reduction, but it would also continue if you relied on general global cooling. Now that perhaps that my assumption there is a bit contentious. So, Ye Tao would think that his planetary brightening proposal would actually deal with the Arctic tipping point, but I think he's got no evidence to suggest that they would. They're accelerating, and we need a huge amount of cooling power directed into the Arctic because that's where the heating is taking place. And Kevin Lister and myself estimated how much cooling power was needed, and we came up to similar figures. So that's recapping a bit of what we were discussing, Rebecca. Roger Arnold, who's here, had noted the Ye Tao thing and said that some of his criticisms of stratospheric aerosol injection were invalid. The business about infrared or thermal radiation blocking was not valid. I think, was there anything else, Roger?
Well, not directly about that point, but regarding marine cloud brightening, it's hard to have marine cloud brightening that was selective for cooling the Arctic. The Arctic is warmed about 3 or 4 times as much as the rest of the planet. Marine cloud brightening could potentially bring down the average global temperature, but you'd still have a big problem because of the weakened polar vortex, the meandering of the jet stream that's bringing so much bad weather. that would still exist even if you were able to raise the average or lower the global temperature average.
Yeah. So you're agreeing with me there.
Yeah, I'm agreeing with you. You need something that's selective for the Arctic in particular, because I think probably the highest priority issue at this point is to try to stabilize the polar vortex and put a stop to the meandering of the jet stream that's bringing so much turbulent weather.
Can I say something about marine cloud brightening?
Please, Stephen.
Yeah. If you cool anywhere in the Earth, you will reduce the heat that is flowing from the hot places to the Arctic and the Antarctic. So you don't have to do it in the Arctic. You just have to do it anywhere and then wait a bit. The reasons for doing it in the Arctic are that you get a quicker result, and also you are annoying fewer people. And probably most of the people around the Arctic would be quite glad to get their ice back. But that you can do it anywhere. Now, my calculations are very different from John's, and I'll try and explain the way I did the calculation. I'm assuming that if you've got a combination of ice and water together, you've fixed the temperature. That's absolutely fixed, depending on the salinity of the seawater, and it's a little bit under 0 degrees centigrade. Now, if the next thing is you know how fast the ice is disappearing, and you can get that from the PIOMES measurements, which are really quite reliable. If you know that and you know the latent heat of ice, you know exactly how much heat you'd need to remove to stop the ice melting. Okay, and the solar input in the Arctic, just for a short 2 or 3 months either side of the solstice, is actually higher than the equator. So you can calculate from that how much you need to reflect of the rather high solar input coming in. And that's where I got the calculation. Now the problem is, it's assuming that the heat that is coming in the form of warm water and warm air has not changed, and we're assuming that that's constant, and that may not be true. And when I ask people if they have a number for it, they don't know. If they'd given me a number and how much it would change, I would have a lot of confidence. I agree that it's an uncertainty, and assuming that it hasn't changed is a little bit dodgy. So nevertheless, that might be a factor of 2. But this gives me really quite a lot of confidence in the mass and latent heat of ice argument. Okay, then that's a very encouraging. I was amazed at how a few spray vessels I'd need to do that, even just for 2 or 3 months. Right. Okay. Now, I think the thing where things are maybe going wrong is that if we look at the difference of the solar heat, if there's all the ice there or no ice there, that is a tremendous extra gain. So the question is, are you going to wait until all the ice is gone and then try to recover it? Or are you going to hope that there'll be some ice left in March, and that therefore you've got a high reflection at the beginning of the heating season? So that's where the big difference is. Now, John made a lot of other assumptions in his earlier calculations, which assumed that there was a much lower cloud fraction than there actually is, and he didn't take account the higher solar input in the high latitudes, and there were various other things, I think, but the main one was that he had assumed that all the ice had gone, and we had to try and bring it back. Does that help?
Thank you, Stephen. Rebecca?
Hi. Could I say, Stephen, I found that very helpful because it's elucidating or saying with words what you've already written down, which I'm familiar with, and which is in our what we call the MCB pitch document, which is on item 2 on the agenda. John, in relation to what you said a few minutes ago, so I'm just going to do playback here. when I say just, it's not that easy to do it, but in this group, we are all agreed we need cooling, whatever verb we want to use, but cooling. We are agreed that SRM is one of the methods, along with refreezing bright ice, Leslie Field's kind of techniques. So there's a whole range of nature-based techniques or things that mimic nature. So that's the second thing we're agreed on. What we have put into the MCP pitch document, which I think you agree with it too from what you said a moment ago, is that we need someone to sit down and document the sort of things Stephen was just saying and what you've said yourself. You've spoken with, I don't even know the person's name, but another climate scientist. So what we need to do is map out at the highest level. This is what I call a top-down estimate of or methodology for assessing the climate cooling power of various SRM techniques. So that is a top-down thing, and at some point when we have the time, the money and the mental energy and organisation, we need to commission, this is my suggestion, a few experts to say, here are the questions, here's Stephen's approach, here's what John and the other chap have found out. Please compare and contrast and provide us with your view of the top-down methodology. So that's one thing. The next thing is...
Sorry, Rebecca, could I just respond on that?
Yeah, certainly.
David Keith has already suggested that, and he commented that a research program to properly assess the various SRM techniques would require a research program costing around $2 billion, and that would save the expected cost of $10 trillion, and so would have a 5,000-to-1 benefit to cost ratio. And so the idea of a small informal group commissioning work on these issues is, I think, is slightly misplaced, because what's required is the strategic vision of the need to cool the planet. And once that strategic vision, then the appropriate research involving the appropriate formal institutions can be possible. And I really think that we're, chasing our tails by saying that we, in isolation from governments and universities, can provide useful comments on these highly complex questions that involve massive field research and broad academic study.
Well, okay, Robbie, I agree with that. And by the way, everyone, Robbie and I spend about 2 hours a week normally chatting one-to-one. So we're never at odds with each other, or very rarely. I agree with what you've said. What I am saying is, can we please frame our own discussions in terms of what you just said? We are pipsqueaks and we haven't got the time and the money, and we have got the intellectual expertise. But David Keith has said that, what you've said. So instead of saying, for example, climate scientist X says, here's the estimate from a top-down point of view, and climate scientist Y, which is Stephen, has a different way of estimating it on the back of an envelope or a spreadsheet, let's just say it is a job that needs to be done the top down. And what we need to do instead is get on and find, this is my main point, get on and find together some small practical ways of getting started with cooling the planet. And what I now want to say, and I actually don't want to get into item 2, but just on that point, Stephen and Alan Gadian have done amazing bottom-up methodology to assess the power of MCB, and I think it could also be used to assess the power of another thing that Clive and Franz are working on. So what I'm saying is, let's stick to what we're really good at, which is small methodology. When I say small, I mean detailed bottom-up calcs, and Stephen and Alan have written something up. So I'm just going to finish with one final point, which is now not a playback, but a new thing. The film that I posted up the top there, I'm sorry that my mouse is making a noise, it's an old-fashioned mouse, but the thing that I sent, the video, is called Can We Cool the Planet? And it's about the water cycle and regeneration. It is from someone called Adam Long, who met with Stephen recently, and he's been travelling around Europe talking to experts in Prague, and I think he's in Zurich at the moment. And of course, John, I'm sorry you didn't get a spot in the video, but Stephen's in the video with MCB. So but the actual reason I put it there is two reasons. One is that it's the most powerful thing I've seen for a while, or for a long time, on the problem, right? It's referring to the 2019 terrible black summer fires that we had when our whole east coast was burning and 1 billion animals died. So that's sort of saying, hello everyone, we're in a bad spot at the moment, understatement. And then the next thing is, what can we do about it? And then he goes into a lot of short information about investing to change the water cycle, and beautiful examples from Australia, and I think it was from Rajasthan, citing certain experts there. What he's called Rajendra Singh is one of them. And then he then segues into, can we also look at MCB? And then he also says at the end of it, this is what we're going to do research on. And wrapping up my little soliloquy here, he says things like, we need to understand all of the SAI techniques and all of the pluses and minuses and pros and cons. And so it's sort of like our own Prague manifesto, if I may say so. And like, I'm sure that we don't want to spend, it may be even a good use of time to spend 5 minutes looking at the video now rather than later. But in any case, we're all on about creating a storyline, and that's what I have to say at the moment.
Thanks, Rebecca. I'd prefer to use our time for our conversations and encourage people to look at the video later. Now, I wanted to go back to John and ask further questions on the SRM storyline. John, were there further things that you heard?
Yeah, there was a general point that SRM was too specific and didn't cover some other cooling methods, which is fair enough. And because there are methods like cloud removal. Cloud removal in the Arctic winter would be a very powerful technique for increasing the outgoing thermal radiation. We know that the cold nights are cloudless nights, and that because the clouds are blankets for infrared radiation, thermal radiation. So yeah, so my storyline needs to be clarified on that.
Can I say something about your winter thing? It's possible, if you believe the work by Olteskar and Christensen, that very small aerosol in the Aitken mode will actually remove clouds. They're saying that this is happening in the low latitudes, but it would also happen in the high latitudes if we can make it. And the reason that I think if I understand them correctly, they're saying that if you have the aerosol too small to nucleate, it can still take a lot of water out of the atmosphere, but not make reflecting drops, because there's such a large number of them. All right. Now, I did send, I think, a note about the possibility of using the same spray vessels in the winter time with a different size of aerosol as a way of clearing the clouds in the winter, and that would be a very effective way of cooling through the winter. You'd let a lot more infrared out to deep space. A way that we might be able to make the very small aerosol is to use diluted salt water to have less salt in it. It's not the size of the drops that matters, it's the mass of the salt that you're spraying. So there is a possibility to do that. I don't want to push that until I understand a bit more about the Olteskar, Christensen, Aitken mode stuff.
Thanks, Stephen. Daniel?
Yeah, just a quick question, and I'm not an expert in this, but Stephen had said before that the Aitken mode generally resulted in variable size droplets. So I'm a bit confused on this.
Well, the whole of the Aitken mode, according to Altersgaard and Christensen, could be warming rather than cooling, and they're doing it by clearing cloud. So I think there might be a particular spot in the middle of the Aitken mode that would be really right for this, but I don't know what that would be. The Aitken mode is fairly wide, and there may be a sweet size that we should go for. I've actually got enough wafers in the present design to have some wafers for small drops and some wafers for big drops, or some wafers for fresh water or only slightly salty water, and others for the normal. So we could do this with really very little change, provided that the Altersgaard Christensen effect is correct.
Let's hear from Herb then, Jonathan. Sorry, John, do you mind?
I was just going to respond very positively to that, Stephen. That sounds something that we should definitely include in our portfolio. And I suspect that the result of cloud removal would be more dramatic than cloud brightening, actually, for the Arctic.
But you can use the same. We could only use spray for the Arctic for 3 months in the year. The rest of the time we want to send them off to stop El Niños or modify hurricanes or work on sea level. They're a versatile tool. You can put them anywhere you want and leave them as long as you want, and you may be able to tweak the size of the spray that they're releasing. And they're also very much cheaper than airplanes.
The problem is in winter you've got the sea ice to contend with for your ships.
All you need to do is to be somewhere where what you're doing will be blowing there. You don't go into the ice. You go up to the ice. The wind will
propose doing marine cloud brightening in the Arctic winter. Look, let's go back to
so marine cloud brightening is not the right term here, but okay.
It's cloud clearance.
Cloud clearance. Yeah.
Okay.
It's the same tool.
Yes. I enjoyed reading your storyline, John. I guess the major comment I have is that I don't think anyone who is skeptical of intervention would get past the second or third sentence you wrote, because you only spent, and I don't have it in front of me right now, but I've had it earlier. I think you only had a sentence or so or two on why emission reductions won't do the job. And 98% of the world believes that emission reductions, as we've said, over and over and over again, is the way to go. And so I don't think anybody's going to read it past that statement. So, and let me just give you an example. Coincidentally, since this meeting started, I received an email from Al Gore, not a personal email from Al Gore, but I was a graduate of his training program some years ago, along with a few thousand, several tens of thousands of people around the world. Obviously, I don't need to say who Al Gore is and how much even today, even though he's not as, as prominent as he was a decade ago, how much influence he has. And it's inviting me to a seminar with him. But I just want to read one sentence at the very beginning of the email. The science is clear. At net zero emissions, global warming stops almost immediately. The Earth starts to heal and temperatures can begin to fall within years, halting climate devastation and opening the door to a sustainable future. Now, correct me if I'm wrong, but to me, that couldn't be more inaccurate and just absurd, an absurd scientific statement from somebody who is the world's leading proponent of climate action.
Well, it's and the consensus, Herb. Like the issue is that the IPCC.
Well, let me just can I
assessment 6th assessment report. Sorry, yeah, go on.
Yeah. No, I'm just saying that that's what we're up against. And I by no means am critical of all the technical stuff you're doing, because that needs to be done as well. So don't get me wrong, but I'm just saying, I say this in the context of the storyline. And I don't think you need to spend more than a couple sentences. I'm not saying you need to write a whole lot, but to me, it would be that even the most drastic and dramatic emission reductions can only slow the melting of the ice. It can't stop it. It can't reverse it. I mean, that's scientifically, I think, non-controversial, or whatever other language you want to use. So
Yes.
that's my point. This is what we're up against. I already signed up for attending Al Gore's webinar next week, and I hope I'll have a chance to challenge him on that statement that was said there. I do that about 2 or 3 times a day on Twitter to people like Michael Mann, who, that's what people say. Well, we get to net zero and warming stops. Nobody says, well, warming may stop, unless you accept the Hansen approach. But whether you do or you don't, even if warming, quote unquote, stops, it stops at 2 or 2.5 degrees C. Sea levels continue melting. I don't need to say that to you all, that the effects of climate change continue getting worse in the best circumstance, if all we do is rely on emission reductions alone. So anyway, just to summarize, I think you need to hit harder, or else you won't get people to read past the very beginning.
Okay, thanks. If you could send us the bit of text that you've just quoted, that would be a help. From
Okay,
Al Gore.
yeah, I'll put that in the chat right now if I could figure out how.
Thanks, but
Thanks, Steve.
that's certainly worth a very good point there.
Could I just quickly comment that Doug McMartin, like this has been a point of debate on our lists for a considerable time with David Keith, Michael Mann, and various people critiquing them. Now, Doug McMartin made a comment about a month ago, which my impression was that he endorsed the zero emission commitment consensus, and he suggested that it was obvious. Now, Doug McMartin is a scientist for whom I have the greatest respect, and I was really surprised at his comment. And I think engaging him on this topic in a bit more detail, because he does tend to be quite dismissive of people and in quite a cursory way. And so exploring these issues in more depth is immensely valuable, because I think that the most distinguished critiques of the zero emission commitment concept, which is what underpins Herb's point, comes from people like Tom Garreau and Ye Tao, and so I fully agree, Herb. That's it's such a critical debate.
If I could, I just maybe slightly disagree with you. Because I think my argument is, even if we're willing to accept the zero emission commitment, we'll have, we're still going to be at 2 or 2.5 or whatever indefinitely. Sea level will continue to rise. Ice will continue to melt. Even the IPCC acknowledges that. So rather than, I'm not against, trying to marshal the scientific arguments against that, but my logic is to say, we'll concede that we still will have completely unacceptable impacts and consequences. We still need cooling, even if we accept that. And if and if the Hansens of the world are correct, that's even more of a reason to do it. But in other words, not to pin our argument on on weakening or questioning the zero emission commitment. That's like a bonus, if you will.
Well, they're very much related, and I think my interpretation is that the people are in a state of psychological despair and wish to hang on to something that they can find hope. And I certainly find hope in albedo enhancement, and I think that that's a scientifically based argument. But there's a mass movement that finds hope in emission reduction, and then for scientists to exaggerate the potential impacts of emission reduction feeds that popular myth of false hope, which I think you're absolutely right, Herb, that confronting those opinions is just essential. Okay. Now, yeah.
I
go
just
on,
want
Herb.
to say one, just very quickly. I responded a few weeks ago on Twitter to Michael Mann actually making this case, which I think it's self-evident that if we get to zero emission commitment, it will be at a temperature significantly higher today. It'll take us decades to get there of all sorts of consequences that are horrible. And his response to me was very critical. I was surprised he didn't block me, because he's notorious for blocking almost anybody who slightly disagrees with him. But I think because we've had some positive interactions. But all he said was, well, this is repeating the discredited comments of many of the opponents of climate action. He didn't make any substantive response, which I think the reason I mentioned it, I think it fits with what you've just said, Robert, that even he is holding on to this and is so afraid of acknowledging that even the best case is unacceptable.
Thanks, Herb. Let's hear from Jonathan. Now, Daniel had his hand up also, but he's taken it down. So,
Yeah,
Jonathan. Sorry, Daniel, do you want to quickly speak before Jonathan comes in?
Yeah, I was just going to back up the point that Herb made about the need for near-term cooling, because it talks about horrible consequences. I mean, literally the in Europe, and there's a lot of areas where people haven't got air conditioning. If these continue to ramp up, and it's expected, I think James Hansen said that next year is expected to be generally hotter than this year. We're getting against the limits of livability in terms of people being able to function day to day, and these extreme temperatures are actually, I mean, I've heard in the US the prolonged nature of them is already getting it's at record levels, above 45. I think it was Phoenix or somewhere that they're having sustained long heat spells, and those night temperatures not coming down. So you're getting to those limits already. So we're talking about in the next couple of years we might get sort of really, and there's not, agriculture isn't in the news headlines. I mean, in the UK it's all about the extreme heat affecting people, but in the meantime you're getting the frazzling of our crops, and that's going to feed through to literally the food industry, and you're going to get raising prices. All these are going to cause a lot of instability, and these are all consequences are going to be major in the next couple of years.
Thanks, Daniel. Jonathan?
Great, thanks. Yeah, my question is for Stephen. I'm working on a demonstration and a story, and I've had pretty good success with it, but I'm not sure that it's true. It helps to convince people of the exciting prospect of marine cloud brightening. And here's how the story goes. A lot of students that are now adults have seen the demonstration of a supersaturated solution suddenly crystallizing or dropping out a precipitate. And I reference to those that they've seen, and sometimes I show them one. And then I explain that there are regions of the ocean, it may only be 5% or 10%, where there's no dust at all in the air. And because of the wave action, there's very little salt in the air too. And the air is sort of super saturated and ready to form clouds, but there's no nucleation. And that if a ship went through that area and sprayed out something to nucleate, that the amount of cloud that would come off would be like an eruption or a precipitate from a supersaturated solution, which is the air in this case. And then they get it. But I want to make sure that I'm right. Are there areas of the ocean where the particle count is so low and the vapor pressure is so high that the clouds will just erupt off the back of these ships, you know, obviously in a time frame of minutes or hours or days. But is that a true description?
Unmute, please, Stephen.
Yes, it is true. It takes time for the aerosols to move around. It doesn't happen instantly, and it actually has been filmed, and I was there, and I can show you some stills from it. It was filmed by Discovery Channel, and the place they did it was Layaplek off Southwest Africa, and the air there had come up from the Antarctic and was incredibly clean. And they released some aerosol from cloud seeding flares, and about 10 minutes after they'd done that, a cloud appeared from a completely clear blue sky and spread out and gradually got bigger and bigger and bigger as the material moved along. So it's quite true. It's a bit surprising, but it can happen. You're right. But it takes time for the stuff to move around. If you look at the mean free path of air molecules, you'll be able to calculate how long it's going to take. If the wind is not blowing, and if the wind is blowing, you've got the spread of turbulence. I don't think it's a thing to worry about, but you're right, it could happen. And it was air mass that had been exceptionally clean.
And what percentage of the ocean do you think might have that characteristic?
I need to get someone who knows a lot more about it than I do. I think the person to ask would be a chap called Danny Rosenfeld, who has worked. He's from Israel, but he's worked in the Southern Oceans, and he is saying that the effect of marine cloud brightening is double what I thought it was. But the ice crystallizing is a lovely experiment to do, but it does need the shock of some tiny little bit of fragment to begin the nucleation process. But I don't think it would be like an explosion.
Right.
Something to add about
I
that.
find that the supersaturation analogy really communicates well to people, because to a young student, it seems sort of magical that the professor can put one drop of something in a gallon of liquid and suddenly the entire liquid turns blue, or a bunch of white precipitate drops out or something.
Yeah.
And these kind of impressive demonstrations, I think, can capture the mind better than the idea of saying, well, there were clouds there before, and then what we did increased their reflectivity by 10%. That sounds kind of mild compared to supersaturation.
That's much more likely to be the case. But the supersaturation, the reason that we went to Layaplek was that people said it's always got the perfect clouds there, always. And when we got there, it was a completely clear blue sky. There wasn't a cloud in the sky at all. And we kept telling them, John Latham and I were there, and we said, look, we can't make clouds. We can only make clouds that are already there be whiter. And they wanted to film us looking stupid, which is why they went ahead. There's much better television than an experiment that works. And we kept saying, no, it's not going to work. And they did it, and it actually did work in a very dramatic way. And I will send you all the stills from this.
Look, thanks very much, Jonathan and Stephen. That's really interesting. I want to check, Roger, were you wanting to speak?
Yeah, supersaturation is very common, but it's a phenomenon of the upper, higher atmosphere. It's very unusual to have supersaturation at sea level, because you have to have a warmer air mass that picks up the vapor in the first place. Normally, supersaturation occurs as a result of air rising and cooling as it rises because of expansion. That's, of course, how thunder clouds form all the time. But it's hard for me to see how you can tap that at a low elevation, just above the sea surface. There would certainly be some cases where a breeze blew over warm water and then to a cooler area, where you would have supersaturation at sea level. But that's a relatively unusual phenomenon, I believe.
It wasn't dead at sea level, and we were using a flare which was really quite hot, and so there would have been some rising to get it started. It didn't happen instantly. It was a few minutes after we released the flares.
Well, if you did an area where there's convection carrying the air upward,
Yeah.
then that would effectively provide radiation centers.
Yeah, and a chap in an airplane flew through it and made measurements of the nuclei.
Mhm.
Look, thanks. I'd like to move on. I'd just like to commend John Nissen for sharing the SRM storyline. I think it was it's such a good starting point, and I think there's been a range of really useful suggestions, and so I hope that can get some good results. Now, I'd like to move on to our next point, which is our MCB discussions, and so I'd like to introduce that by giving a bit of background. So, at the conference in Cambridge last month on albedo enhancement, Alan Gadian was there. A few others were there, and also before that conference, I was able to spend some time with Stephen in Edinburgh, working on where things are at with marine cloud brightening, and Stephen was able to invest in a large workshop for climate engineering and related technologies, and also equipment for that. And I think Stephen's initiative in providing this support is of immense value. Now, Cambridge continues to work on with support of the Blue Cooling Initiative on how marine cloud brightening can possibly work, and several of us, including Daniel and Alan and Rebecca, see the high value in supporting Stephen's leadership in taking forward, in seeking investment to study the next steps for marine cloud brightening. And so we've prepared a draft business pitch deck to seek investment, and the amount that we propose to seek is $5 million. And the key issue is that if you look at the analysis that, for example, Diamond et al. Produced of where marine cloud brightening is at, there's a whole series of oceanographic questions that will need research. But the initial point that needs to be proved is that submicron monodisperse particles can effectively be produced. And so it's this the generation of MCB is the first major point, and we see three areas that need work, and that's firstly the technology itself, and Stephen has developed quite an extensive proposal on how to prove the ability, and as he mentioned earlier in this talk, the wafers using to produce nozzles of various designs in a wind tunnel with various specifications. So that's the major guts of what's needed, and then the other areas that need work are computer modeling, and Alan Gaden is an expert on that at the National Centre for Atmospheric Science at Leeds University, and then because a lot of the modeling work that's been done within the GeoMIP community has had assumptions which can be challenged. And so giving Stephen the opportunity to take some intellectual leadership on what questions should be modelled and work with Alan on that would be of immense value. And the third major point is messaging, and the whole need to engage in public conversation about marine cloud brightening and related issues. Now, I should have mentioned, of course, that Brian von Hertzen is also part of our group who've been developing this proposal, and Brian's position as leader of the Climate Foundation gives us the ability to tap into the resources of the Climate Foundation to administer and manage grant funding, which is what we'd like to obtain. And so Brian's success in marine permaculture in obtaining an X Prize grant is of immense value in creating a proposal that we think should be of high interest. And in the context of George Soros remarks at the Munich Security Conference this year, specifically endorsing Stephen's work, it's of great value. Now, we would like to partner with several of the other MCB researchers around the world, and we principally see the Cambridge Centre for Climate Repair and the work connected to the MCB group at the University of Washington, and also the MCB field trials that are underway for the Great Barrier Reef in Australia as the leads in that space. So that's the overview of where we're at, and we look forward to sharing a pitch deck when it's agreed with a broader audience. And I'd invite Stephen to. Sorry, I'll make one further comment, and that is Doug Grant has been also engaged with the discussion. Doug's argument, and which has created quite a lot of conversation within our small group. Doug's argument has been that Stephen's proposals for the autonomous deployment vessels have flaws, and Doug argues that unless we include an analysis of the deployment method at the start, then our whole project will fail. And I feel that that's not a good view. That what we need to do is prove that we can generate MCB before we even start seeking money for the deployment of MCB. So anyway, that's where we're at. Stephen, would you like to add to what I've said?
Okay. First of all, the only reason that I started working on the spray vessels was John Latham asked me to do this. He had worked out all the stuff about Toomey, and he heard that I was working on an idea for making the sea evaporate faster by spraying much bigger drops. And he asked me if I could design the hardware. So that's where I began. I think if we hadn't done this, people would say, but how on earth are you ever going to get the spray produced? So I was quite glad to have some ideas. I'd be very, very pleased to hear from anybody who's got worries about them, because the more I get the worries now, the better chance we have of sorting them out. So perhaps you could ask your Doug, whatever his name was, sorry, to tell me what he doesn't like about spray vessels. I'd be very grateful. I like to have problems early. Okay, I'll tell you now a bit about the experiment I want to do. Everybody who starts thinking about this thinks about the diameter of the spray. And the trouble is that if you understand the Kohler work, the diameter of the spray varies according to what the local relative humidity is. And what you should forget completely about the diameter and just think about the mass and the chemical nature of what you're trying to spray. And I've heard from Cambridge that troubles they had trying to measure the drops, and they said it was none of the measurements agreed, and it was all different and horrible and miserable. The trouble is they were trying to measure the size of a liquid drop, and that is completely meaningless unless you know everything about the mass of salt and the relative humidity. So the plan is to make a ring of air inside a plastic tube, and you can get very cheap plastic in a lay flat form. It's mainly used for making shopping bags, but you can get any width you want. And I'm going to get a 40-inch wide lay flat tube, which has got two lots of 40 inches. So that'll give me a 600 millimeter diameter, minor diameter toroid, and it's going to be 10 meters in diameter. And the next thing I want to do is to take some air through a deep freeze to bring its temperature down to -18, and that strips all the water vapor out of it. And I can put it through a ULPA filter. That's a really super quality filter to get all the dust and aerosols out of it. And I can warm it up again and pump it inside this circular, very dry, very clean air tube. So now I've got my test tube, and this is my test tube. I've got control of its humidity and its pollution and everything. With all the people who are trying to work in the open air, they are sharing their test tube with 8 billion other people who are not telling them what they're doing with their experiments, but just generally making a complication, and you've got no control at all. Chemistry really got going when people started using pure chemicals and clean test tubes. And that's what we have to do. We want to be in control of every experimental variable. So now I've got this very clean air, and I can blow it round the inside of the toroid, and that'll mean that whatever happens inside is going to have a fairly even concentration. We don't want to do it with this stuff that's just come out of a jet and is very uneven. And then what I can do is I can inject some salt solution of known concentration, and this will evaporate very, very quickly because the humidity is so low. And then I'll have this cloud of salt particles zooming around this torus. They won't fall very fast because they're so small, and if you work out how the free air, still air falling speed, it's completely negligible compared with the turbulence. And then what I can do is I want to put in a number which is going to give me anywhere between 50 to 100 to maybe 1,000 nuclei per cubic centimetre. And I can do that exactly by choosing how long I do the injection for. It'll just be a few seconds. And then what I can do is I can add various amounts of liquid water as a fine spray, and that will now condense on the particles and we'll get drops. And I can work out how fast, I can control how much water I'm putting in and watch how fast the cloud drops are growing. And I can continue this with them swirling around, and probably to get to the size of approaching a raindrop, I'll be having to go for quite a long time, a couple of hours perhaps, but I can watch this process and count it with a laser instrument called a Malvern Spray Tech. And that'll tell me everything
Stephen,
I need.
I think, I mean, we've just got 20 minutes to go, so I really appreciate that summary of the technology. But what I suggest we do is invite Rebecca and Daniel to comment on where this process is at, if that's okay. Rebecca.
Hi, everyone. what I think is we're iterating between the detailed science, which Stephen has just outlined, and we're using a Google Documents methodology to save the working papers so that they're all in one place and the working group can find them. I've been enjoying writing them up and putting them into a table of contents so that every piece of work that Stephen does has a place in the project, and we know why has he produced it and is it relevant with which stage of the project. Like, it's obviously a series of projects, but when is it relevant for, that kind of thing. I also think that our expertise of the group in preparing exactly what we tried to do even in item 1 today, a storyline, is really a very pleasurable thing for the people in the group at the moment. We're working out how to message what Herb said, and Herb's still there. What's the problem and why will this help? How does it deal with net zero and all that? So we're kind of iterating from big picture down into science and then back up into messaging. So I think that's, oh, hi Herb, nice to see you. Maybe you're eating your lunch or your dinner or something, whatever time of day it is there. Anyway, it's a very enjoyable project, and I think what we've all been doing is not wanting to share it widely early because it gets quite chaotic with different version control and everything. But perhaps even in the next fortnight, like, this is up to Stephen, he's the project director, but it may be appropriate to send it out for paid comment in the next fortnight. The one thing I also want to say is that Alan Gadian is totally and utterly focusing us on which particular experts can be involved, what money do we need to pay them, what's the politics of certain people. There are cuts going on in various different universities, which is, that's been happening here in Australia as well. It's probably continual, but we haven't quite placed it yet with the budget amount, and working out who can do what and who wants to do what and who should be asked, sponsoring, and not the small project team, but the next layer down of who's actually going to be involved in this stage. So until that is all sorted, it is sensitive and can't be shared. So I hope that's a good summary.
Thanks, Rebecca. Let's hear from Daniel, and then Jonathan's got his hand up as well, but first Daniel.
Yeah, as I said initially, I thought it was a really good start to the messaging and the document in terms of what, Robert's initial format and the sort of depth of it and everything. And I think it's good we're getting some figures in there and some other things. I'd recommended adding more weight to it by bringing in Stephen's company and see Alan Gadian's organisation as well. So it seems like a bigger thing. But in the background, I'd been working with Stephen on some branding issues, I thought, and I thought it was good when you had it before, just talking about Stephen. But if you bring in a company, I'm obviously being a marketing person. Basically, it turns out I've got a fundamental difference of opinion with Stephen on the branding. So that's something that I'm finding not the most easy thing to compromise on the document. I know that, Robert, you tried a good compromise between two logos on that, but that's something we'll have to resolve somehow. But obviously, I think
I just want to concentrate on being an engineer.
Yeah, that's what you said it previously to me. I can see that you're more than an engineer. You have your like an artist. You have your view of how you want to portray how you want your art to portray your engineering prowess, and I can see you have that particular idea. And I won't go into that, but just say I want to focus on other areas of that. But I think I'm very much about adding weight to the organization as a whole. And having worked at a company, as my day job, where they've sort of spent ridiculous amounts on rebranding and that sort of thing, I can see the value in some of that. If I can
thanks, Daniel. Let's hear from
other
Jonathan.
areas, I'm happy to do that. Yeah.
Yeah, thanks. I just have a quick question. Whenever I have my hand up, it's probably just a quick question. So this is for Stephen. Stephen, the apparatus that you were describing for the controlled measurement, is that like are you envisioning a 1 meter by 1 meter by 1 meter apparatus, or a 10 meter? How big is this apparatus?
It's 10 meters in diameter. Okay, for that's what you call the major diameter of the torus, and the minor diameter is 600 millimeters. And it's got a sag in 2 places so that you can get material draining down and be collected. If there will be salt in the end of an experiment, and I want that to trickle down and leave very big lumps of salt, which won't be getting into the airstream. So 10 meters by round for the big ring, and 0.6 of a meter for the minor diameter.
Thank you.
Look, okay, so Stephen, did you want to comment again?
No, that's it.
Thanks. Look, I think that's a useful overview of where we're at. Can I just check if anyone else would like to ask any questions on the MCB agenda point? Otherwise, we'll move on. Thanks very much, everyone. So now the final agenda point that we had was the wording that I used for it was climate cooling effects, which was something that we've actually already had a bit of a conversation on in the context of the SRM storyline. But it's this broad question of how do we assess the merits of different methods, and it links to this question of the zero emission commitment. You know, what's the cooling effect of Al Gore's assertions? You know, how what's the process for assessing that? So happy to hand over to anyone who would like to comment further on this topic.
Can I have a word here?
Please.
I'm sure that the James Hansen pipeline argument is very, very strong, and it's getting people to understand that. But there are 2 other points you could make that might appeal to the doubters. The first is that when you put a bit of toast into the toaster, it doesn't go brown immediately. It takes quite a lot of time, maybe a minute, for it to turn brown, and then maybe it'll go black if you leave it in there. So this gives people the idea of things not happening instantly, and the idea of time constants and the time it takes to get to 2/3 of wherever it's going to get to. And this is really what James Hansen is saying, and what Mann is not saying. So that's the delay. The second thing is that there's about 40 times more CO2 in the oceans than in the atmosphere. We've been putting it in for a long time now. Some of it gets turned into calcium carbonate and some of it gets turned into plankton, but there's still a hell of a lot of CO2 in the ocean, and it can go from the atmosphere to the ocean very quickly, and it can go from the ocean back to the atmosphere very quickly if the vapor pressure of CO2 in the atmosphere is reduced. So you're not dealing with the amount of CO2 in the atmosphere, you're thinking about another source of it where there's 40 times more. So this gets people into realizing that just net zero is desirable, but it's completely inadequate. And then you can bring in the idea that it could be done, provided that you had time travel. And the money and funding and research we're putting into time travel is completely negligible. So we must blame all our decision makers for not funding work on time travel if we want to get net zero to be actually useful.
Look,
All right.
Stephen, you've raised this time travel point, and it's really just a joke because time travel is completely impossible. and so the merits
It's
of
not. It's not actually. Einstein says you can do it. The trouble is you have to be moving at the speed of light or close to a black hole. Yeah. But anyway.
anyway, it's like
Yeah.
it's like it's a sort of way of saying that fixing the climate by emission reduction alone is physically impossible. And I prefer to try to stick to the literal statement rather than make cynical jokes that many people won't get.
They might remember that though. They might remember the joke.
Yeah, that's true. But also they might not get the joke, and that's often the problem. I'm just going to share a diagram that I made a while ago about the best outcome from net zero emissions. The circus trick of balancing plates on sticks. Now, it's entirely possible to do this in a stable way as long as you keep moving the sticks. But as soon as you stop moving the sticks, then the plates fall down. And to me, that's like what they're talking about is let's allow the temperature to rise to 2.5 degrees, and then above. And then keep it stable at that point. And Al Gore seems to be saying that then the temperature will start to fall, but it just completely ignores the risk of tipping points. This whole literature around tipping points is just assumed to be zero from this zero emission commitment literature. So it's there's such a big problem within the IPCC modeling that various people have commented that whatever is not can't be measured is assumed to be zero, and that's just a basically flawed scientific method. Rebecca.
Since we've only got 8 minutes left, I would like to make a wrap-up comment, which is probably back under agenda item 1. Clive, Ellsworth and France. I'm slightly changing the topic off this one, if that's okay.
Of course, yes.
Thank you. Clive Ellsworth and Franz Oester are quite far advanced with yet another methodology, which is very, very, very similar to MCB, but using what they call artificial Löss dust, which is clay, but it's artificial so that it doesn't have certain of the problems of clay. The good thing is the science is pretty similar, plus the deployment is going to be pretty similar. So in terms of getting alternative methods up and running, that one can piggyback almost, I would say, 85% on the work that our little team is doing to get the MCB up and running. Watch this space, because Clive is presenting to Bright Spark and Methane Action on Wednesday UK time, and after that he's going to circulate the slide deck to everyone, and I think it will blow your mind, because it's got slide 2 is directly dealing, anyway, I won't say what it is, but that's one parallel activity that's happening. The other one is just repeating, if you really want to make yourself feel happy and think that your grandchildren or your whoever, the animals in the backyard and everything, have got a future, do have a look at that video that I circulated, because that's yet another stream. The basic thing on there is what I'll just quickly say. It's about regeneration, and it's a lot of work that's been done here in Australia about how if you create little water holes, then it saves the water, and the area around the water hole becomes green and regenerates. And in droughts, those particular farmers that have been doing that have had greenery and etc., and ecosystems. And the particular value add that Adam Long's group is doing is the infrastructure to create little creeks all over the country. So it's sort of like greening the Sahara, well, they're not talking about that, but it has been done in Rajasthan, and he wants to get it going here in Australia. So anyway, what I'm really saying is that a metaphor, something like all rivers are leading into the Tigris, and from there that it will all go into the ocean and so forth. And I've got a lot of hope at the moment.
Thanks, Rebecca. Now we've got 5 minutes to go. I'd just like to invite John to make some wrap-up comments.
Okay. Well, thank you very much for the support on this idea of a storyline. It obviously needs strengthening, and I think one of the there are a couple of things that need strengthening. We need more to explain the IPCC position and what everybody has been told, why it's wrong, why it's well, it's totally inadequate to just rely on zero emissions. So that's one strong thing. Another thing is to broaden SRM to include cloud removal or whatever Stephen suggested, clearance. I think it was cloud clearance. We ought perhaps also to discuss surface methods, which we haven't done today. And the other thing we've discussed today is to get round the table and do the actual calculations necessary, because Kevin and I have agreed on various things, including how much extra heat might be going into the Arctic. I mean, we base that on various things people have said about the temperature of the ocean rising in the waters entering the Arctic, and what kind of volume that is. So we should do this, because we shouldn't be saying that we can do something when we can't. I think we need to reassure people about stratospheric aerosol injection. It has got a terrible bad name. Immediately you talk about SO2, sulfur dioxide, people think of acid rain, and it's a nasty chemical and it smells horrible. Actually, when it's very dilute, it doesn't smell horrible, and you get it in forests, and then phytoplankton blooms as well produced a kind of forest smell as well from the sulfur dioxide. So we have to do a lot more persuasion on how on stratospheric aerosol injection, because it is our best bet at the moment for refreezing the Arctic. I think we have to face up to that, whether we like it or not. So that's my conclusion.
Thanks. Let's hear from Herb then, Daniel.
Yeah, I just wanted to mention, I don't know if anyone, hopefully, whether you saw my post yesterday, maybe because it was Sunday, some people didn't see it, where I put that New York Magazine article that just came out a couple of days ago that extols the need for geoengineering. And as I wrote in that post, I've never seen a general magazine article that positive and that sophisticated in, I mean, not only saying why we need it, but why the moral hazard argument is bullshit, and almost all the other arguments against it are bullshit. So I strongly encourage you to take a look at it. And again, as I wrote, it's a little misleading because the headline was focused on the that white paint proposal, but after 3 or 4 paragraphs, the author, for whatever reason, excuse me, made the the sort of the general pitch. So if you haven't looked at it, please look at it and, you know, circulate it, use it, quote from it. It's, you know, I think hopefully, you know, the last thing I'll say about that is David Wallace Wells, who I think most of you know, was a writer for New York Magazine 5 years ago. And he wrote that path-breaking article pointing out that the climate crisis is much worse than mainstream climate science has indicated. And it made a huge difference. And this is in the same publication, a different writer. And I think if we do everything we can to amplify that article, and maybe it can begin to have the same kind of impact that David Wallace Wells article had some years ago. So that's what I want to say.
Thanks, Herb. Daniel?
Hi. Yeah, I was just going to ask John, just after obviously Stephen's explanation of his figures for cooling requirements for the Arctic and talking about the latent heat. And then Stephen mentioned that John had just, in his figures, assumed that all the ice had gone at that point. Is that the case, John, in your figures and Kevin,
no.
that you were assuming the Arctic without ice bringing the ice back? Or
In the calculations, Kevin, we ignored the extra cooling that you needed to refreeze the ice. We just concentrated on the albedo loss, which could amount to 1 watt globally averaged. That means half a petawatt focused of heating focused in the Arctic, which is why you need to direct your cooling into the Arctic, which you could do not necessarily by direct cooling in the Arctic, but by cooling the water flowing into the Arctic, which fortunately most of the water north of 50 degrees, most of the surface water, including big rivers, are flowing towards the Arctic. So if you cool there, you're mimicking what Milankovitch cycles do when they change the climate by either giving a warming signal in the northern hemisphere, summer, or a cooling signal. They bring on the ice ages and the interglacial periods. It's all done through that amazing mechanism.
Thanks, John. Look,
so the amount of extra water heat entering, so that both the albedo and the extra heating of the water, which we estimated heating of the water using completely different approaches, and came to roughly the same conclusion. I mean, we can only do things, by a factor of 2 or 3, but we still came to a conclusion that using marine cloud brightening, as defined as marine cloud brightening, was about an order of magnitude too little, which is I'm devastated by it, and I can understand Stephen being feeling it's
the change between now the water flowing in from Siberia from what it was when when there was plenty of ice. We're looking for the difference, not the absolute amount.
Yeah, that's what we've been estimating.
Okay, we'll continue this debate at a later date.
Yeah.
We've come to the end of the meeting today, so thank you very much, everyone, for joining, and I'll circulate the recording and appreciate the conversation. Thank you all.
Thank you, everybody.
Thanks.
Bye bye.
Okay, bye.